So, of course, it's a great pleasure to introduce my colleague today, Eric Smith, and partly because he's not just a colleague, he's a friend of mine, and he's a collaborator at the Institute. And tonight's lecture, as you know, is on the topic of life, the inevitability of life, and its origins in relation to geochemistry. Now, one of the unfortunate tendencies of the human mind is to think categorically, to think in terms of dichotomies, living, non-living, conscious, not conscious, good and evil. But of course, the world is not categorical, it's more continuous. And of course, this tendency to categorize extends to institutions, departments, physics departments, biology departments, literature departments, architecture departments. And for those of you who've been coming to these public lectures, you will know that the Santa Fe Institute often stands in opposition to a rather simple-minded categorization of the world, both institutional, intellectual, and metaphysical. Now, the topic of life, of course, derives some of its charge from the sort of categorical, dichotomous opposition it stands in relation to in the inanimate world, to non-life. And I wanted to read you a quick quote from Mary Shelley's Frankenstein. This is the preface that she wrote to the book in 1818. Many and long were the conversations between Lord Byron and Shelley, to which I was a devout but nearly silent listener, so presumably she couldn't get a word in. During one of these, various philosophical doctrines were discussed, and among others, the nature of the principle of life, and whether there was any possibility or probability of its ever being discovered and communicated. Perhaps a corpse would be reanimated. Galvanism had given a token of such things. Galvanism, of course, being the application of current to muscles and their subsequent contraction. And of course, there are other stories like the golem. The golem is mentioned in the Talmud, where Adam, in fact, was first a golem, made from dust, and the famous golem, of course, of Prague, the 16th century Rabbi Lowe, who constructed a creature to work on the Sabbath out of the mud of the banks of the River Volta in Prague. And of course, more recently, computer viruses, which some people think are alive. Now, all of these narratives, Frankenstein, viruses, and the golem, life springs from physical and chemical processes. It doesn't spring from existing life. It's not like birth, where living things spawn living things. These are non-living things spawning living things. And at some point in the history of the Earth, presumably there was no biology. And some disposition of chemistry and physics gave rise to biology and the subsequent evolution of life. And these are the things that Eric's going to talk about. Now, Eric has done his fair share of raising disciplinary boundaries. He was an undergrad at Caltech, where he did his degree in mathematics and physics. He was then a graduate student in Austin, Texas, where he worked in string theory and quantum gravity. And then he was a postdoc at Texas and then at Los Alamos before coming to the Santa Fe Institute. His interests include the emergence of life, that he'll talk about today, but they're not restricted to the emergence of life. He's also interested in the correspondences between economic processes, physical processes, and living processes, biological ones, and also the connections between energy, information, and computation. So in tonight's lecture, Eric will ask whether, contrary, I think, to our intuitions, life might not be inevitable in the universe rather than rare. Eric.
Thank you all for coming. David, thank you. Wonderful introduction. It sets just exactly the right tone. because in a subject where there has been too much oversimplification and too much soundbite reporting, I want to try to give you some sense of the richness and the beauty of the picture that comes up if we ask about the position of life on Earth. So let me stop this thing. So tonight I get to tell you some facts or some new ideas about the emergence of life on Earth that I think will change what many of us have been told about whether we should think that life on Earth is surprising or inevitable, and how we should ask questions like this. At the same time as answering this question, it should change our understanding of the position of the biosphere within the geological world and several important aspects of our position as people or as animals within the biosphere. So there are many different messages that all sort of inform each other. I want to set us tonight the task of answering 4 questions. First one, why is there life on Earth at all, as opposed to nothing or as opposed to an empty rocky planet? How and where did it originate? Sort of obvious questions of mechanism. Why has life persisted? This is important because I think if we have a sensible understanding of how life emerged, that must also make it sensible that life has stayed, because the things that cause it to persist are the same things that caused it to emerge in the first place. So the questions must be asked and answered sensibly together. And then, last of all, does the biosphere contain relics of emergence, so that by looking at what life is today, we have a window that's informative about how it came into existence? Now, before I can address any of these sort of forward-looking questions, I have to address a question that has been a problem in this topic, which is whether science can say anything about these problems at all. And of course, since I'm here on behalf of the Institute talking to you about science, you would think that this is a foregone answer. But if we poll some influential 20th century scientists, in particular biologists, the returns we get are a little bit surprising. So let me start with Stephen Jay Gould. I actually chose my talk title tonight as a response to Gould's very wonderful little book called Wonderful Life. Many of you will probably have read it, and it had a big influence on me with my first exposures to biology, and it's a really important work of this century. Gould chose the title for his book on the basis of Frank Capra's 1946 movie, It's a Wonderful Life, because he felt that the movie told exactly the story he wanted to tell. It's a story that an individual's actions can have permanent and important consequences. And Gould's message about biology was that for the first time in science, things that seem to be accidental can have consequences that could last forever. So, of course, being Gould and fighting the last war against oversimplification, he states things in the strongest possible terms. Any replay of the tape would lead evolution down a pathway radically different from the road actually taken. Now, if you take this at face value, or in the context of the book, it makes it sound like accidents are all that matters, which kind of leaves us wondering, what then is the role for science? Not the same as in the other sciences, maybe. Gould, of course, worked with things that are big enough to see without a microscope and that can leave fossils. Let's go to somebody who works with things that are smaller. This is Jacques Monod, who the year I was born, 1965, won a Nobel Prize in Physiology and Medicine for his work on the regulation of cell machinery from the gene. Monod wrote a lasting, influential book called Chance and Necessity. His concern was one that we've heard many times. a wish that people not imprint human notions of purpose on biological descriptions of how machinery works. And he was interested in arguing against two things in particular, the two ways people tend to imprint purpose. One, vitalism would have been a claim that when matter becomes part of a living thing, it's no longer the same as other matter, and we can't understand it. The other, animism, which says, well, it's all matter, but it all has purpose from the beginning. I think Monod's point in arguing this was to try to bring biology closer together to the other sciences and the way they're understood. But of course, Monod was primarily a guy who explains how machinery works. And how machinery works doesn't necessarily provide a good explanation of why it's there at all or how it got there. And so faced with this difficulty, he makes a statement that, if anything, is even stronger than Gould's. He says, the biosphere does not contain a predictable class of objects or of events, but constitutes a particular occurrence, compatible indeed with first principles, but not deducible from those principles and essentially unpredictable. So he starts out trying to bring biology together with the other sciences, and with this sort of encapsulating statement, if anything, it makes biology seem even more remote from the other sciences and leaves us wondering, what can we say? But the granddaddy of them all, as far as strong statements, is Francis Crick. Crick, together with Jim Watson, discovered the double helix structure of DNA and first realized that this was the molecule that could be responsible for heredity and the way it works. And Crick takes this sort of accidentalist viewpoint of Gould and Monod all the way back to the beginning by associating the emergence of life with the emergence of something like DNA and heredity. So early, you see him here, he's looking sort of appropriately like a sorcerer, presumably lecturing on the structure of the molecule that's the key to life itself. And I think a lot of people have tried to think of DNA in those terms, and I'm going to try to push back a little against that tonight. But he refers to the emergence of life as a happy accident, and a little bit later goes on to say, the origin of life appears at the moment to be almost a miracle. So many are the conditions which would have to have been satisfied to get it going. Now, if there's one thing we know science does not claim to be able to talk about, it's miracles. So while this is not necessarily a logical impossibility, it seems like a very strange point of view for a scientist to be putting forward as a scientific conclusion, because it amounts essentially to throwing up one's hands and saying, oh, we can't say anything about that part. So if there is ambiguity in the public's understanding of what science has to say about the emergence of life, I think it would not be blamed on the public. Maybe we should start by looking at the things scientists have said. But if there's ambiguity, it should be leading us to ask three important questions. As one of my favorite political commentators says, what were they thinking? Specifically, what aspect of biology are these people looking at that would cause them to draw such seemingly odd conclusions? For us, what's important is this really science? Is this the nature of life that they're talking about? Or is it actually a nature of their point of view, which might be narrow and might have left things out? Because if it is just a prejudice that comes from not having looked at everything, and we can broaden our perspective a little bit, maybe we can find that from a bigger perspective, there's a story that's not all about accident, and that's truer to the nature of life, not necessarily to the history of science. So that's what the rest of tonight is supposed to be about. So,